welcome and thank you very much for joining us today in a journey to map the field of consciousness science. We start from the big assumption there is a field of consciousness science, and we try to map it, showing you what you see in the back already as a little teaser, 40,000 papers that we think are a good backbone of consciousness science. My name is Moritz Kriegleder. I'm from the University of Vienna. I have a background in cognitive science and physics. And this is my colleague, Max Noichl.
Yeah, I'm Max Noichl. I work at Utrecht University at the Department of Theoretical Philosophy. But I'm doing like a lot of data science-y, computational social science stuff. So most of the data analysis part of this project, that's stuff I've been doing. And Moritz, he's the guy who did like all the groundwork for how to build like a sample of consciousness science.
Well, I just came up with some topics based on some reviews, but yeah. So today we will talk a bit, like this talk is supposed to act as like a discussion starter. So what is the state of consciousness science at the moment? Why do we meet here for models of consciousness 5 already? Is there some common ground that we can all agree on or start from to look at the different perspectives that we have in consciousness science? So like the main approaches that you usually see are like philosophical, neuroscientific, empirical, and computational approaches. We already today had different perspectives with like all these 3 approaches there. But as you probably know, with the interdisciplinary effort of mapping something as multidimensional as consciousness, you run into the usual interdisciplinary problems, which are mainly problems of communication. We use different vocabulary, we maybe have similar ideas, but it's hard to translate them from one discipline into the other. So we kind of wanted to try to give a kind of like an overview that can act as a common ground for people to refer to when they discuss specific aspects of consciousness. And for this, we looked at 3 recent reviews and used the database OpenAlex to extract 71 theories of consciousness. We're open to discussing this number with you, so if you have any feedback, we're happy. And that gave us around 40,000 papers, which we then, Max will talk a bit about the machine learning approaches we use to make a map of them, cluster them according to different perspectives, and label these clusters to identify kind of like the subfields in consciousness science at the moment. So yeah, starting from the conceptual idea, when I entered the field, it often seems that there is like a single discipline project going on when people come up with models of consciousness. You usually have like neuroscientists who work on some specific phenomena, and from that they try to build like a grander theory of consciousness. Or you have like here, especially at this conference, a lot of physicists and mathematicians who take a very specific aspect of consciousness and build kind of like this bigger theory of consciousness from it. And obviously you have a lot of philosophical discussion where people start from philosophical assumptions and what these assumptions change in the way how we try to model consciousness. But something that Vilas and collaborators called the multiple explanandum problem arises, that we have a lot of these different dimensions and different phenomena that we kind of collect under this umbrella term of consciousness. Just a couple of like differentiations that have been made in the literature is like the discussion between level of consciousness, like wakeful states versus coma states or sleep states, versus structural approaches, which want to study the structure of subjective experience, for example, in perception. Another distinction that has been often discussed is by Ned Block, the phenomenal versus access consciousness distinction, where phenomenal refers to subjective experience specifically, and access consciousness is about our ability to report. And another different kind of perspectives that have been taken, I also seen that today this discussion already arising, is if consciousness is a property that is kind of like identifiable, like for example mass in physics, or it's a process kind that is about what systems do. And the question here is, how compatible are these perspectives with each other? And do they even have to be compatible? Do we need this one singular explanation that covers all of these dimensions of what we in the literature describe to be consciousness? Or can we have these philosophical, empirical, and computational perspectives as kind of complementary to each other? And so we believe that we need a common ground when we have a discussion, and the common ground could already start from at least staking out what we think consciousness science as a field is, what is the state right now, and what would be goals of future research. Has anybody been to the discussion session D in the morning? Okay, good. Me neither, because I posted the question that was discussed there, but we were still fixing our talk, so I didn't go there. So the discussion session was about this meta-scientific perspective. What are the goals of consciousness science in the short term? So if we can kind of agree where to go next. Oh, you went there? Well, I'm sorry. Maybe we can repeat that after our talk. Okay, so my literature review is pretty small, so I'm very happy to get some feedback from you if you think that like our representation of what consciousness science is not capturing specific aspects. But I identified 3 recent reviews, one heavily discussed by Seth Bayne from 22, another very interesting review by Signorelli and colleagues. I don't know, maybe someone is here who can say more about that. And a huge literature review put out this year by Kuhn, where there's like 150 pages of basically, I don't know, a lot of theories of consciousness that have been published over the years. From this, we identified 71 theories, which is a pretty arbitrary number. I was just going through these reviews, and we decided to stay with theories that at least make some predictions or have some empirical content. This was a pragmatic decision because first, if you put like idealism and realism as a theory of consciousness in a scientific database, you get millions of papers who are not talking about consciousness, but about like philosophically more fundamental debates. So we wanted to try to stake out something that has empirical content, which maybe in the near future could be tested or compared against each other. We use the database OpenAlex. It's an open, transparent database. You can just try it out yourself. They have like 260 million papers or something. And from this, we got 83,652 papers that kind of correlated to the keywords from the 71 theories of consciousness. And we mapped them by semantic similarity. What that means, Max will explain in a second. So this is our list. I hope we can scroll down a bit. I'm not going to go over all of them now. You're happy to check out the list and the map later. And if you feel like we're missing out your favorite theory of consciousness, let us know. Oh my, someone is actually reading that. Nice. Okay, good catch, good catch. Wait. Yes, this is something we would be happy to discuss in the questions and answers. Okay, so the goal of this map was kind of to take a step back and look from the outside what's going on in consciousness science at the moment. We used some machine learning methods to look at a broader structure, because 40,000 papers is probably something that like a regular PhD could not read like in like 3 years. I mean, I couldn't. So I'm very happy that machine learning is doing that for me, at least like getting the structural similarities. And this could also help as a kind of reference database where people who are interested in a specific field want to see the connections to other fields that are going on, kind of like in the spirit of building bridges with other approaches that you maybe haven't encountered before. So you can go into the interactive investigation in a minute, and Max will show you how we made this map.
Okay, so just a quick question. How are we doing on time? We have another 10 minutes? Okay, that's perfect. That's lovely. Great. So thank you, Moritz. I'm going to very quickly walk you through the data processing we did. So basically, we have this nearly 40,000 articles, and for all of these, we have abstracts and titles, which we're going to use as the base for our mapping. And what we're doing is basically we're embedding those texts using a language model. We're using specifically Spectre 2, which is a model, I'm going to go into a little bit more detail on that in a second, which is trained to classify scientific texts more broadly. We're then going to, so embedding basically just means turning your texts into long strings of numbers, and with the hope that these strings of numbers encode the similarity relationships between your texts. And what we're then going to do to these long strings of numbers, which are basically vectors in a high dimensional space, is we're going to do dimensionality reduction on them, which means squishing them down into 2 dimensions. Presumably losing a lot of information on the way down to 2 dimensions, but hopefully keeping like the most important, most interesting structures intact, which we're going to do with a process called uniform manifold approximation and projection, short Umap, which is relatively recent nonlinear dimensionality reduction method. We're also going to separately cluster these embeddings using a, I think, pretty bleeding edge experimental clustering algorithm called EVOC, which is neat because it's a clustering algorithm that works directly in the high dimensional space, has a notion of noise, which is very useful, and is multi-layer. So you don't get like one clustering solution, but you get like multiple clustering solutions at different stages of granularity. And finally, what we're going to do is we're going to label the clusters automatically using Anthropic's Claude Sonnet 3.5 language model, which just means for each cluster, we are selecting the journal names that are like most specific to the cluster. We are selecting some keywords for the cluster, and we're sampling a number of titles. And we're giving them to the language model and saying, hey, given these things, suggest to me the name of the field for this area. And this is like, I would say it's a little bit of a sketchy process, right? As we know, LLMs can be a little bit finicky, but on the other hand, if you have to label, I don't know, 300 clusters or something, it does spare us a lot of work. But probably when we're going to move this towards something publishable, we are going to do that by hand, or at least doing a lot of double checking on these clusters. All right, so just to go into a little bit more detail of what our language model is doing here. So the embedding language model, Spectre 2, is basically trained to solve a number of science tasks, which can be clustering, classification, regression, predicting various things from scientific texts. I've taken a graphic from the precursor paper of Spectre 2, Spectre 1, which kind of explains like the main training process this model undergoes. And this is just start with another model, in this case Cybird, which is like a bird style language model, and fine tune that by giving it a query paper, which can be, I don't know, something on quantum consciousness, giving it a related paper, so another quantum consciousness paper cited in there, and giving it an unrelated paper, which can be easy negative, which would maybe be something on, I don't know, prostate cancer or something, a completely unrelated paper, or giving it a hard negative, which could be a paper that is like 2 citations away or something, so same probable subfield, but not exactly the same discussion, and training this model to kind of learn to tell the difference between those two and kind of incorporate this additional information about the structure of scientific fields into the encodings of the scientific language. And basically, we're going to take this model off the shelf as it was published by Allen AI And we're going to use that to encode all of our texts. And then we're going to, as I already said, push these encodings into Umap. And I've just given you here a little graphic from a paper of mine where I try to explain how Umap works, just to build some intuition. So the basic idea is just using those embeddings and measuring similarities between these embeddings using something called cosine similarity. We build a nearest neighbor graph. So each article gets linked to its nearest neighbors as measured in high dimensional space. Then we're reweighting this graph in a certain way, and then we're going to do something that's just basically a graph layout in 2 dimensions. So we're initializing, in this case with a spectral embedding in 2 dimensions, and then iteratively we're pushing points closer to each other which are linked according to how strong their links are, and pushing points apart which are unrelated. So the map that you're going to see does not have any edges, but what's lying in the background is basically this reweighted nearest neighbor graph. And so you can think maybe about this map in a similar way as you would think about other network layouts. All right, so moving on to the final product. This is what our map of the science of consciousness looks like right now.
Yes, Wi-Fi is working.
Wi-Fi is working? Amazing. So just to give you like a little bit of an account, each dot here is one individual paper. As I said, paper that talk about similar things should be really, really close to each other. Some areas of this map, as you can see, have been like really pushed to the outside. These are areas that are not actively linked to the main body of this mapping, which means that their positioning is not super interpretable. I should also mention that we can't really interpret like the global axes of this mapping, right? Like there's no meaning to being like on top or at the bottom or on the left or on the right. The only thing that's interpretable is like the local relationships to like your roughly related points in your vicinity. Okay, would you like to take it from
zoom
here?
a little bit, but we will give you a QR code in a second. So this is online, so you can play around with if you want to. So basically, the most important thing that is like you can click every point to directly go to the paper. So you can use this as a reference, but also just to look at a little bit like what kind of clusters exist. I mean, obviously, philosophy of consciousness is a big cluster that we kind of started out from. So you have a little bit down there. Oh,
Let's go back.
well, Mac works differently. Thank you. How do I?
Oh, now you've messed it up.
I told you it's Windows. On Mac it works perfectly. Also on iPhones works perfectly.
It also does work on Windows. I don't know what you're... All right, here you go.
But like, can you zoom? Can you go down or not?
Yeah, you just go like with 2 fingers up and down.
But like,
Ah.
I want to go down. Okay, now I can drag. Thank you. I don't know how Lenovo works. So if you start, for example, from the philosophy of consciousness cluster, you can look at related fields, for example, neurophilosophy or free will discussion. We then can go to machine consciousness, which is kind of a ambiguous field. It's not a beautiful cluster. As you can see, like every cluster has its own color. So if you get more colors, okay, we are showcasing just a minute of this. In the south here, I clicked again. I love Lenovo. If you go to the south, you can see the neuroscience clusters. There's a lot of disorders of consciousness, computational neuroscience. You have some global workspace and higher order theory stuff there. Have a look around for yourself. There's some visual consciousness. In the very west, we have this nice cluster of active inference and free energy principles. I've been working on free energy principle for some time. And our map kind of shows a little bit of outlier position that active inference has in the consciousness science debate. But what? The Wild West. The Wild West, yeah, that's even here. What is it? Exploiting unintended feature leakage. Okay.
Oh yeah, I think there is some active inference bleeding over to engineering robotics.
Yeah, exactly. So you also find some applications like in active inference. You have like cognitive robotics. And of course, you also get the phenomenology cluster. Something that is interesting for this discussion at the conference is the artificial intelligence, ethics, and consciousness cluster. But have a look at it yourself. We're gonna give you the QR code. You can play around with it. We're happy to get some feedback. We also just posted it on Twitter. So if you want to join the Twitter discussion of like, why is my favorite theory not there? Please do and retweet us. Yes. One last thing I would like to mention is this should help to build bridges between the different fields. And here are some projects we like that actually try to do that already. And we're looking forward to your questions. Thank you.